Hey there. So next tutorial we are going to do is going to configure SSL and TLS on Amazon Linux 2. The previous video was installing LAMP stack on Amazon Linux 2, so feel free to go through that if you do not have one. And we'll go ahead and get started. So the prerequisites. We need to launch an EBS-backed Amazon Linux 2 instance, which we did. Configure a security group to allow SSH, HTTP, and HTTPS. So in the previous video, it did not enable HTTPS, so let's go ahead and do that now. So here's my LAMP stack that I built in my previous video, and for my security, I'm currently using a demo security group. And what we're going to do is we're going to edit the inbound rules, and we're going to add a rule for HTTPS. You can either search for it here, or you can just do TCP and type in the port if you know the port number. And then I recommend using your IP with a subnet range in case your ISP changes your IP, which they will from time to time. And then that's it. So that's done. So then we need to install Apache web server, which we already did, and PHP and MariaDB, we already did that too. Identify and authenticate websites. The TLS PKI relies on DNS. To use your EC2 instance to host a public website, you need to register a domain name for your web server or transfer an existing domain name to an EC2 host. You can do this on numerous third-party stuff or use Route 53. So I'm going to go ahead and show you this. I have a domain name, and I registered mine with Route 53. And you can see that by going to the Route 53 service. Super easy. It's actually really cheap. The hardest part is finding a name and then finding a name that's available. So you can always just create, you can register a domain. So if I wanted to be like jakeisawesome.com and check if it's available, it's probably not. Then it'll tell you, hey, jakeisawesome.com is not available, but I can do, look at that, Dr. Jake. I like their thinking. You're looking at $12 a year, you know. Jakeisawesome.link, $5 a year. So some of these more strange suffixes have cheaper costs, but find something that you want, and then you put in your contact, your address, your phone number, stuff like that. Whether or not you want your information to be public, if somebody looks up the domain, you verify, and then you purchase it. Like I said, $12, great deal. Word of the wise, if you have an Amazon billing alert set up for like $10 or something like that, and you get an alert, don't be scared if it comes in a couple days, because that's just you buying your domain name. So worth knowing. So if I'm gonna go ahead and go back. I don't need to do this. Once you have one, it lives in this area called hosted zone. So I have a hosted zone for nimbusdevops.com. And in nimbusdevops.com, I've got my A record, my NS record, my SOA, all that stuff. So I have a hosted zone. I have a domain. So this is what I'm going to use. So if you don't have one, go ahead and get one. If you don't want to spend $12 and don't want a domain, then you don't have to do that. But if you use TLS, you have to do that. So assuming you're here, you're going to do that. So first thing you do is turn this sucker on. So we're going to go through this process and do a self-signed digital certificate. So for what we're going to do, this is fine. For production, it's not. If you expose your self-signed certificate to the internet, visitors to your site are greeted by security warnings. So if you've ever been to a website and it has the little red warning and you have to accept like the risk and continue to the website, it's probably because somebody's using a self-signed cert or an expired certificate. So if you're doing this for production, what you'd want to do is you'd want to go to a certificate authority and have somebody actually sign your certificate and you have to go through an identity verification process to make sure that you can verify who you say you are. And so your domain, you can get a certificate, you can manage that. AWS has some services for that, but we'll talk about that later. But for now, we're just going to use self-sign. Just don't do it at a enterprise production level. So we connect to our instance and make sure it's running, which ours is, so it should be no problem. Enabled. Cool. If the return value is not, then you enable it. All right, and then we want to make sure all our packages are up to date. I just ran this, but we'll go ahead and run it again and let that go for a little while. Sweet, it's done. And then now that your instance is current, you add TLS. So what we're going to do is we're going to install the Apache module mod SSL. Step 1. You need mod SSL. So that's done. So now you have these ssl.configuration files. So conf.d/ssl.conf. And we can make a certificate for testing. So let's just go to this directory and see that. And there, ssl.conf. There we are. You'll notice that there's also a php.conf. So there's some other stuff that's going to come here by default. The configuration file for mod SSL. It contains directives which tell Apache where to find encryption keys and certificates. The TLS protocol versions allow and encryption ciphers to accept. So we can take this dummy cert script, and it generates an X509 cert and a private key for our server host. The certificate is useful for testing Apache is properly set up to use TLS. So a lot of times when you're testing this, you can actually test it with a self-signed cert and get it to work before you go get one signed, just to make sure your configuration is correct. This doesn't provide proof of identity, which is why you get that warning, so you shouldn't use it in prod, which we'll be able to see, but we want to go ahead and run that. So yeah. So run the script to generate a self-signed cert, dummy certificate, and key for testing. So we'll see here, we've got this little make dummy cert. And then there's a run the script to generate. So if we go to this directory at cpki TLS certs, and in here we can run this script make dummy cert, and we're just going to make one called localhost.crt. Okay, and there it is, localhost.crt. So now we have this file. It specifies, the specified file name matches the default that is assigned to the SSL certificate file directive in here. So if we come into here, let's go take a look at this real quick. I'm just going to cat this file. And you can see, where do you live? All right, so listen on 443, port 443. Dialog there, random, crypto built in. It's going to use the built-in crypto device for that. That's where our logs are going to live. The SSL engine is on. Level 3 is the protocol. I'm just reading what's not commented. All right, here we go. So right now it's configured to point to the SSL certificate file variable is set to point to our localhost.cert file. And the key that it's going to use to decrypt this to make sure that a request is valid is going to be this localhost.key. Okay, so that's basically how this works. If you have questions about handshakes and all that stuff, I mean, go Google it. It's a fascinating thing. The file contains both a self-signed certificate and the certificate's private key. Apache requires the certificate and the key to be in PEM format, which consists of base 64 encoded ASCII characters framed by begin and end lines, just like this. You may have seen this before if you've ever been messing with SSH keys or PEM keys. So the file names extensions are convenient and have no effect on function. True. For example, you can call it .sir or .pem or whatever, so long as it's related to this directive, that variable thing I told you, it's called a directive. So long as it's related to that directive and the file is the same name, then that's what it's going to use. Special note: when you replace the default TLS files with your own customized files, be sure they are in PEM format. So now we can open this file and comment out the following line, because the self-signed dummy cert also contains a key. If you do not comment out this line before you complete the next step, the Apache server fails to start. So remember when we saw localhost.key for the certificate file? We're going to go ahead and comment that out. So easy way to do this, we're going to copy this, and we're just going to VI this file, and then we want to comment out the localhost.key, SSL certificate key file. So you can just copy this, do a little, this guy is the one we want. Let's do an insert, oops. All right, where am I at here? SSL key file. There we go. So we're just going to comment that out by putting a little bang in front of that dude. And that's it. Write and quit. Oh, are you kidding me? I have to do this as sudo. Sometimes I forget I'm not always root. Alright, so now we go down to our key file, SSL certificate file key. Comment that sucker out, and we're done. Then we just restart Apache. The reason we restart Apache is because Apache needs to reload this configuration so it knows what to do. Make sure port 443 is accessible in your EC2 instance, which we did. And then we want to, Apache web server should now support HTTPS over port 443. You can test it by entering the IP address or full qualified domain name with HTTPS at the beginning. Alright, so I was using my PHP admin before. So this is our IP, not secure. And this is it with secure HTTPS. So this is the warning because it's self-signed, because attackers might be trying to steal my information. So you just click advanced. You can read through all that. I don't know if I allowed myself to access these things. I think I'm in an incognito window. No, I'm not. So Chrome is doing it. This will probably work later. No, probably not. So what we can do is I can go to the certificate, we can take a look at it, and you can see the root certificate is not trusted, and that's because it's self-signed. So I can put this basic policy to say always trust. When using the certificate, always trust. Hit OK. Reload this sucker. And now I am not getting, oops. Let's go back and read through this one more time. Make sure I didn't miss a step. Because I can't override the warnings. Let me see if this is a Chrome special Chrome problem. So let's copy this and use Safari. I think this is the first time I've ever used Safari on my Mac. Show details. If you understand, you can visit this website. Visit this website. There. Now we're using secure because I have this little lock. I'm curious if it'll let me do it now that I did it in Safari. No, usually in advanced it gives you an option to keep going, but it didn't. So, but I got it to work in Safari. My Chrome settings are pretty strict, so that's probably why. Okay, so that works. Step 2, obtain a CA sign certificate. So you can use this process, kind of what I was talking about. So you generate a certificate signing request from a private key. Then you submit that to a CA. They sign it, and then they sign that. They send you back a host certificate, and then you just configure Apache to use that certificate instead of the self-signed one. So let's go over this really quick. Self-signed is cryptologically identical to a CA sign. The difference is social, not mathematical. Like I said, you need somebody to verify your identity. Okay. It costs money. You can use Let's Encrypt to do it. I know that's like a really common one. I think they even rotate their keys every 90 days. I wonder how much this costs. So if you were to get one, let's say we want to get started. Protocol, blah, blah, blah. For operating system, web server. With shell access, without shell access. Okay, they recommend certbot. Okay, so we want to get this. So we can say, find out if your hosting provider has HTTPS built in. No certbot needed. So I am running Apache on, it's really like CentOS. Was there a, oh, it was pip. So you need to be comfortable with the command line, have a website that's online with port 80, that's hosted on a server you can SSH to, and the ability to sudo. There you go. So if you have those, this default, you can install this. I'm looking for how much this costs. So really it just gives you some commands and then you run it and then that's it. I don't know whether or not this actually costs money or if it's free. Kind of looks free. But if we just go look up, I wonder if there's all these donate things, but for real, like how much does it cost? So let's take a look here. CA cert cost. Number of certificate creates in the month per region. So Amazon's is like 75 cents a certificate, so that's not a bad way to go. So you could probably go through Certificate Manager and get one. I'll have to do a video on that. I'm not going to do it today, but anyways, so we've got SSL turned on and I was able to get that up and running. So the signed certificate part I'll probably make a separate thing for, just because it's pretty long and kind of boring. And then you can test and harden it, and it's like, oh my god, now you're really getting in there. I can't believe this isn't a tutorial for EC2. I would think that this is a little heavy-handed. Yeah, here's some certificate automation. So yeah, we'll take a look through this. I'll make a separate video on that, on obtaining a CA sign cert. But basically all we did was enable TLS. So we were able to at least get to this version of our site with HTTPS. So anyways, I hope that helps. I kind of had to go through a little bit of troubleshooting to get through this done. So if you're going through this on your own, then hopefully that helps you. And if you have any questions, feel free to ask. If not, then hooray for certificates.